Hello everyone, I'm Xiao Gang. We wrote out this blueprint node in the last lesson, but there are still many problems, right? It's about when exactly this thing gets called. When does it get called? Actually, it works like this. It does it through a dynamic multicast delegate. In fact, we only need to care about this dynamic multicast delegate. Now let's continue writing our underlying code. First, we definitely need an action ID, right? Because you need to identify what kind of action it is. So, for this ID, we'll have it generated during construction. And similarly, we have an enum here. This enum is passed in from here. So we also need an enum here to indicate the type of time we are currently using. We'll just let it use the local one by default. Okay, after this is done, now let's come back and look at this method. Actually, our constructor should be written like this. Why is it written this way? Because we found that our parent class is written this way. So you can just write it this way as well. Let's go back here. Okay. We still need to modify the constructor here. Okay, we've made the changes here. Let's take a look at what the parent class constructor does. The parent class constructor actually has this. That is whether it currently has this flag. That is whether it is this CDO object. If it is not a CDO object, we give it a strong reference on frame. That is the frame we generated. Do not receive it. GC it. That is what it means. Because this is a U class, so this object will be GC'd. So with the save it through some method, its lifecycle is mainly saved through these two methods. We did not directly add it to the root, because its parent has already provided us this saving method. The first method is preferred, which is to attach it to R on this GAM instance. Then the second method is to essentially cancel, that is, unregister it from the GAM instance. So we only need to care about these two methods. Then back to our place. So how is this object created? It is created in this way. Obviously we need to leave one out here, right? Here we prepare such a pointer and we call it acceptAction and we give it blue object. Okay, pay attention to this object. It can actually be easily recycled. So let's first copy the data inside it. First, we need to on this object, on this instance object, we call this activity, the type of access time it requested. Then we register it onto our game instance. Then register with game instance. At this point, we only need to pass a C context. Then we return this object back out. Let's take a look. There seems to be some issues here. Let's see what the problem is. Let's check. Prompt here. Operated. Let's check what this code is again. Let's look at this function. It should be this one. Okay, maybe this part is wrong. Maybe there are two of them here. These two functions. That is dst.wisdom instance. They look the same because it will automatically, maybe there's a problem with the three-handed monster. Just ignore it. Pass a world context here. Then after it creates this, then this will be called. What do we need to do in here? First, we call the parent class. Of course, you don't actually need to call the parent class here because the parent class is actually empty. Nothing is written in it. We still call it here because we might define our own. Such an exact option used in our project. At this point, we will define some common. If there are some common logs or identifiers for the project, mark it here. Then here. Let it execute this method on the next frame. What does this method do? Because why do we need the next frame? Because of my personal habit. I need to offset the execution by one frame. That is, to prevent you from encountering some issues. So I offset everything by one frame. We let it execute on the next frame. Okay, but we haven't implemented the next frame yet. Okay, good. So this is where we actually implement this. Then after the next frame finishes executing, we need to execute this pin on this frame. And this pin needs to be executed like this. That is this dynamic multicast. It means this pin is going to be a pin. So let's change the name. Then the info here, we just use this info. We haven't written the values inside yet, but that's okay. We put it here because it is required here. Regardless of success or failure, it will always have data like this. The data inside might all be invalid because this action is not over yet. It hasn't really started yet. It also failed. At this point, we need to pause. Let's check its call timing. Okay. Let's go back to our blueprint. We have a package error. Let's check the reason for the error. This place has a compilation error. The reason for the error should be here. Actually, here this is the default. That is, there is a default writing for this parameter. We didn't write it correctly here. There is no need to write this equal sign here because this default parameter, it is written like this. Yes, we can start now. Okay, let's go to our level blueprint. Let's have it execute when a key is pressed. And then here, this pin is actually our hot pin. We should mark a date. Print. This is the hot pin. This is the hot pin. Tight. Follow closely. Okay. Then next, we will give him a successful winner. Our side is 全身. Then we can print out this information here. Print out this information. For this information, we might need to concatenate it. Concatenate it like this. To make it easier for everyone to view. Concatenate it because this information is very useful, especially when we are debugging. When you write a plugin, when you need to debug, we need to do this. We need to give a GUID like this. We still use this standard format. This is actually quite annoying to write. It's quite troublesome, mainly because you have to write this every time. Okay, this part is result. Then we give a message. Okay, we give a message. Okay, so let's print this side. Okay, now let's take a look at its execution flow. When we press 1, it calls this node. It calls this blueprint function. It came from the function. Let's look at its call stack. And you can see it's right here. This came through the blueprint VM. It steps through frame by frame. After it steps in, we set a breakpoint here. Then we let it run. It instantiates the object here. Okay, let's go out again. Okay. These are all from the blueprint sequence battle. Let's follow him. Yeah, this place. Let's make him jump over directly. Okay, we just need to look here. Then this place enters the blueprint Mendel battle again. Then call the active method here. Actually, it's equivalent to this step. This step is executed right after this. Yeah, right. Then after this is executed, let's go to the next array to execute this AVT. AVT's intel. Then this pin will be executed. So this pin corresponds to, actually, it means we have moved to the next step. You can see it has reached this position. We can check the log. You can see it here. This pin executes immediately following the previous one. Then we pull this thing out. Now let's set a breakpoint in the blueprint. It actually works like this. We also log here. Request pre-step access time. access time. Okay, then let's add another key point for it to go through. When we press 1, it comes in. Then it goes into this place, you can see. Then it executes, right? Then it executes. Then this 人来应召. This 软来应召, ding ding dong. Then after it comes in, this 人应召 goes backward. It goes to execute this series of things behind. So this place, it is on the main line layer, like this 人应召. Because we have its default, this shadow angle hidden, so we need to activate the subsequent process. We need to do it ourselves. Execute it like this. After it finishes executing, it comes back again. So this process is very convoluted, but very crucial. This is a very advanced, very cool execution framework, okay? So here, this battle will be executed later. Then it goes elsewhere to find other blueprint narrative machines. Are there any other tasks coming in? Okay. This is the code for our blueprint narrative machine. We'll leave it alone. Okay, so this thematic is set up for everyone. It means that now this node, it has already connected its own outer loop. It has been connected. That is how to enter the outer loop. Where to call it after it finishes calling. Where to go. We have already connected it. Then, for our next steps, we will go ahead and complete its actual step-by-step task. Then call back to the main thread, even if it has already succeeded and this unfailed these two terms. Okay, so we will end this lesson here. Now, let's review this lesson again because it is really crucial. Let's go back here. So, in fact, we know that our blueprint will call this method and find such a blueprint node and then complete it inside. This kind of recording of the parameters of the function. After recording, we need to mount it onto our game instance to prevent it from being garbage collected. Then later, we will also let it. After the task is truly registered, we will unhook it. So we haven't written it yet. We will write it later. Then after this object is instantiated, we will call the activate method of this object. We made an asynchronous step here. Here we simulate a task that needs to be executed asynchronously. Then once this task is completed, copy the data into it. Then here we call the main thread, letting it continue moving forward. Tell it that this asynchronous task has been applied for. Please wait patiently for execution. Okay, this is where we actually execute the asynchronous task. You can do a large number of tasks here. For example, things like IO sending HTTP requests, reading, writing, and playing audio and video all can be placed here. Of course, you also need to apply here the resources of other asynchronous threads because here actually still on the game thread because it may also involve some access to uClass and a class. Okay, so this framework embedded in the main engine will be fine. In the next lesson, we will start executing our one-step task.